Hi. So what we just did just here now is to basically derive the series for the exponential function. So we say e equals the limit as n tends to infinity of 1 plus 1 over n to the n power, and that equals 1 plus 1 plus 1 over 2 factorial plus 1 over 3 factorial plus 1 over 4 factorial up until infinity. So we just derived this series. Now the question that should naturally come to your mind is that what about the series for e to the x? What about the series for e to the x? So you have series for e, but we don't have a series for e to the x. Of course, the series for e to the x should be in ascending powers of x, and I will give you for free. It is equals to 1 plus x plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the 4th over 4 factorial up until infinity. So that is the series. So now how can we prove this? Well, the definition is that e to the x actually is equals to the limit as n tends to infinity of 1 plus x over n to the n power. So that is what e to the x means. So in what we just did right now, we were able to at least find the series for e using the definition and binomial theorem. Now we're going to do the same for the exponential function. The exponential function is a function of s. It's actually equal f of x equals to e to the x. But the exponential number, or the Euler's number e, is not a function. It's basically a constant. So although they are similar, but this e is basically equals to f of 1. So there is also f of 2, which is going to equal e squared. Okay, we're going to try to find the general series for the exponential number, and to do that we're going to use the definition just like we did before, but let's forget about the limits first. Okay, 1 plus x over n to the n power is the same way we did. If you recall the previous video, we said the binomial theorem is 1 plus, just for those who missed it, 1 plus x to the n equals to 1 plus nx plus n minus 1 over 2 factorial x squared. Then you have plus n minus 2, n minus 1, n minus 2 over 3 factorial x cubed, and so forth. So this is going to equal 1 plus n multiplied by x over n. Then you have times n minus 1 over 2 factorial. You have an x over n to the second power. Then you have plus n minus 1 and then n minus 2 over 3 factorial x over n to the third power. Now we can get the general term probably by just coming and say, okay, this is going to infinity, and then you see this is n minus 1 and then n minus 2 up until n minus r plus 1, all divided by r factorial x over n to the r power. So this is like the general term for this, but we don't really need to, just that we need to get the form of how our series would be like. So let's start with the first term here. In this case, I want us to be in the same page. So in the first term you have a 1, so this is equals to 1 plus. Now notice that the n cancel out, so you have a x. So we have recovered 2 terms from this series. Then what about this case? Well, you can factor out an n square here. So you have an n square, then you have a 1 plus 1 over 1 minus, okay, minus, although it doesn't matter, but let's be precise, 1 minus 1 over n all divided by 2 factorial. Then you have an x squared over n squared. Now the third term here, you could do something like, you would have n, you can factor out n to the third power. So you would have n minus 1 over n, no, not n here, so you will just have 1 minus 1 over n, so 1 minus 1 over n, and then you have 1 minus 2 over n, and then all divided by 3 factorial. So you have x cubed over n to the third power, and it goes up to infinity up until you get to n. So you factor out n to the r, so you have 1 minus 1 over n, 1 minus 2 over n, and then 1 minus 3 over n up until you get 1 minus r over n, all divided by r factorial x to the r over n to the r plus, no, n to the r power, of course, plus up until everything goes to infinity. Okay, so we could now say this equals 1 plus x plus, now the n square cancel out, so you have a 1 minus 1 over n over 2 factorial plus 1 minus 1 over n, 1 minus 2 over n, all divided by 3 factorial x cubed, of course x squared here, plus 1 minus 1 over n, and then 1 minus 2 over n up until you have r factorial x to the r. Okay, now if you recall that e to the x, if you recall the definition we've been using, e to the x here actually equal, let me go up and check here. So e to the x actually equal 1 plus x, okay, no, the definition of limit, I mean to say, if you recall the definition of limit, we define e to the x to be equal to limit as n tends to infinity of 1 plus x over n to the n power. So that is going to be the limit as n goes to infinity of what? Everything here. So you get 1 plus x plus 1 minus 1 over n over 2 factorial x squared plus 1 minus 2 1 over n, 1 minus 2 over n, all divided by 3 factorial x cubed up until infinity. So this will be 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the n over n factorial, and so on. So that is that. So this is how we derive the series for exponential function. And thank you for watching. Please do subscribe to the channel. Bye.